let's discuss about trigonometric functions. Now, before we start with trigonometric functions, which you have already discussed and you have studied about this last year. Now, what we'll do, we'll just go around the basics of it once. It's more like a recap for you. Okay. Now, here, to understand about trigonometric functions, we'll start with a very basic circle. So, what you do, imagine you have a circle. Okay. Now, for this particular circle, so first thing what we'll do, we'll take the x-axis and y-axis. All right, so this is the x-axis. Let's say we'll take the x-axis here. And after this, we'll take the y-axis. Now, when you take the y-axis, the intersection point is the origin, which you guys already know. We have the x-axis and y-axis. All right, the origin is O. Now, we'll consider some random point on the circumference, say point is P. P of x, comma y. It can be in any of the quadrant. So, here we'll take in the first quadrant for convenience sake. That's all. Now, the next thing, we'll join from point O to point P. See, when you join point O to point P, see something like this. This is the radius of the circle, isn't it? So, R being the radius. So, you can say R is the radius. Now, from point P, next what we'll do, so we'll draw a perpendicular. Say this point is Q. Now, OQ is nothing but X and QP is nothing but Y. And you can say OP is equal to R. Pythagoras theorem. So we can write x square plus y square is equal to R square. Now this much you know. Now here we have 6 trigonometric functions which you already know. And every trigonometric function is defined as the ratio of particular two sides of a triangle. Right? This is how we define a trigonometric function. Now, if you take the ratio of opposite side to the hypotenuse of the triangle. Now, when we say opposite side, a very important parameter is the angle. Because with respect to angle, we have the opposite side. With respect to the angle, we have adjacent side. Or you can say the perpendicular, base, whatever it is. Everything is based on an angle. So, whenever we say an angle, let's say the angle here is theta. So, how we define is sine of an angle theta. Sine is the trigonometric function. So, sine of an angle theta, sine theta is equal to opposite side is PQ, which is Y. So, you have Y divided by R. Next, likewise, you have cos theta is equal to X divided by R. Correct? And tan theta is the ratio of sine to cosine, which is going to give you Y divided by X. Basic 3 trigonometric functions. And the rest 3 are reciprocal of it, which you guys already know. The reciprocal of sine is cosecant, reciprocal of cosine is secant, and reciprocal of tan, that is the tangent, is cotangent. So these are the 6 trigonometric functions. Now, with the help of these trigonometric functions, the next thing what we have is trigonometric identities. Right? So there are 3 trigonometric identities. Again, it's a recap. So the very first trigonometric identity, we can get it with the help of this particular formula, Pythagoras theorem. See, x square plus y square is equal to r square, correct? With this one, suppose if you divide both LHS and RHS by r square, then you are going to get x square plus y square is divided by r square is equal to 1, because r square by r square is 1. Now, individually divide, you are going to get x square by r square plus y square by r square is equal to 1. What is x? See, x square by r square is nothing but x by r whole square. What is x divided by r? Look at it. X by r is cos theta. Here you have it. See, x by r is cos theta. That means we are going to get cos square theta plus sine square theta is equal to 1. Now, this is the very first identity and probably one of the most important trigonometric identities. All right. Likewise, we have two more trigonometric identities. We'll list out all the identities now. All right. The first identity, that is cos square theta plus sine square theta is equal to 1. First one. The next one, see, this for the same identity, suppose say you divide both LHS and RHS by cos square theta. Then we end up with 1 plus tan square theta is equal to secant square theta. Second identity. Again, suppose if you take the first identity, divide by sine square theta, then we are going to get 1 plus cot square theta is equal to cosecant square theta. So these are the three identities what we have. So the first one is the first identity. Divide this by cos square, you are going to get second identity. The first identity, when you divide by sine square theta, then you are going to get the third identity. Please make sure that you know this, but remember this one. All right. So three trigonometric identities. See, with the help of these identities and with the help of the ratio, whatever we just discussed, we can get to know the value of the trigonometric functions. When I say value, for a particular standard angle, for 0, then 30, 45, like this. Okay. Now, I'll just give you a glimpse of how we get the value of standard angle. Okay. By taking a square and everything. Then later on, we'll just go with the table. Fair enough. So let's start with very simple 30 and 60 will do. Okay. Take an example of an equilateral triangle. Okay. So let's assume that we have an equilateral triangle, say ABC. Now, the angle in an equilateral triangle is 60 degree. So this angle is going to become 60. Now what we do, from the vertex, that is A, from the vertex, we are going to draw a perpendicular. Okay, let's name this point as D. This is 90. So that means this angle is going to be 30 degree. And the property of an equilateral triangle, it divides the side into two equal halves. So when I say it divides, AD divides BC into two equal halves. That means what we know is that this side and this side is equal. Suppose say AC is equal to 2A. Okay, we're not taking it as A, so we don't want A by 2. Let's take AC as 2A. Then we are going to have CD as A. With the help of Pythagoras theorem, we can say AD is equal to A root 3. Alright, use Pythagoras theorem, get the value. Now, one thing I want you to understand is that we no longer use degree. I mean, we do, but generally we have to take in terms of radian measure. So we'll convert 30 and 60 in terms of radian measure. Now, since these are standard angles, I want you to remember these values. All right. So 30 degree will be equal to 30 into pi by 180. Conversion, right? This is going to become pi by 6 radian. And 60 degree will be equal to 60 into pi by 180. So this is going to become pi by 3 radian. Alright. Now take the triangle ADC. That means what we'll do in triangle ADC. Now what we have is we'll start with 30 degree. Sine 30 or sine pi by 6. This will be opposite side is CD and the hypotenuse is AC. This by AC. So what is CDA? What is AC? 2A. So you have A divided by 2A, which is equal to half. Alright. Same thing when you take cos pi by 6. Cosine is adjacent side divided by hypotenuse. Correct? That's how we define cos. Adjacent side is a root 3. So you have AD divided by AC, which is a root 3 divided by 2a. We get root 3 divided by 2. See? Like this, see, for 30 and 60, we are going to take an equilateral triangle, divide it into half. Suppose if you need 45 degree, then you take a square, you divide it into half, as the diagonal half. For 0 and 90 degree, we are going to consider a circle. Okay, so we take a circle because if you remember in the last part of the video, we did sine theta is equal to y by r, cos theta is x by r. With the help of that abscissa and ordinate, we can get for 0 degree and 90 degree. Okay. Now, in the next part, we are going to see a table for a particular standard value. Alright. So, standard value, whatever you are going to have from 0 to 90 degree. Or you can say 0 radian to pi by 2 radian. 90 degrees pi by 2. Okay. What you see is this particular table. So have a look into the table, and these are the values you have already, you guys know the value. It's just that the radian measure you have to know. All right. So this is a table. So go ahead, memorize the table a little bit. You guys saw the table. Now see whatever the values you have. What if you have an angle more than 90 degree? Like what if you have the angle in the second, third, fourth quadrant? Then what do we do? So all those things, based on the sign of the trigonometric function. Okay, so calculating the sign, calculating the value and everything. So we'll look into all these things in the next video.